this is the equation we were talking about. This is what we've been talking about all along, that consumption should be a function of average income and the income of the family, and that if insurance is good, the weight on the income, your own income, should be low, and the weight on the income of the family should be high. That's the idea that, sorry, average income should be high. So beta should be high and gamma should be low if insurance is good. That's the idea we were talking about. Now, this is an attempt to do the same exercise, and it sort of starts to, it uses the data, very similar data actually, collected. Instead of being collected in India, it's collected in Côte d'Ivoire, Ivory Coast. So it's the same data covered in, collected in a different country, very similar data collected, and it tries to do essentially the same exercise, okay? Except it comes from a much more negative perspective. So what is he's trying to do here is showing you a way that, in fact, in his data, this claim doesn't work. It doesn't work to show, the claim that basically household income doesn't really have much of an influence on consumption, doesn't work. Now, one challenge with showing something like that, suppose you were to estimate some equation that looks like this, for those of you who are not used to speaking it of estimating equations, you're fitting a statistical model which has the consumption as the outcome of interest, and two possible regressors. One is the average income, one is the own income, and think about what would happen. So step one in the argument is to think about what would happen. Suppose instead of running this regression, which is what we want to run, we ran a regression where we dropped this. We forgot to put it in. Okay. We didn't think about it. We forgot, something happened. What would happen? So imagine that we started from, the true regression was this one, but we forgot to put in this variable. So when the regression was run this way, beta was, let's say, some number. It was not 0. So it was a relevant. So it was important that average income was important in this regression, but we forgot to include it. That's what's called an omitted variable. So we have an omitted variable. Something is left out. When something is left out, what happens to what would happen to the regression if I forgot to include it? What would happen to gamma in particular?
It would cause an upward bias.
It would push gamma up. You would explain why?
Because the portion of the regression that was attributable to the average income would then be compensated for with the regular income.
Exactly. So let me restate that. I think that's exactly right. You would see gamma would be bigger than it should be. Why? Because gamma is both picking up the effect of your own income and the effect of the average income, which is correlated with it positively. So when average income goes up, your income tends to go up. So those are positively correlated. So anything that's positively correlated with this and is omitted, it will also be picked up by gamma. So if I leave it out, it's going to basically make gamma look bigger than it should be. Is that an idea that makes sense? we're trying to pick up the effect of y, but in the process we also pick up the effect of y bar. Why? Because y bar is not included in the regression. So basically anything that's correlated with something that we include but is not which should be included is going to be picked up by the will be picked up by the things that are included. So anything that we leave out will be picked up by things that are included. So since these are positively correlated, I'm going to get an higher estimate of gamma than I should. Is that an idea that I'm not showing you a proof of it, so it should make some intuitive sense. I suppose I know that income and parental education are correlated, and I look at the relationship between your education and your parents' income. Okay? And I forget that your parents' education is also correlated with their income, then the effect of income is going to look bigger than it should look. Because basically income is picking up both the effect of income and the effect of education. Is that, you should feel, I didn't show you a proof of this claim, but it's a claim that should make intuitive sense to you. So what this exercise is trying to do is to ask in this data, suppose I dropped this thing here. This thing here, if I dropped it, does it change the coefficient a lot? And if it's important, then it should change the coefficient a lot. If this is dropped, this coefficient should go up a lot. Exactly, reverse that argument. I leave something out, it's very important, so it will load onto something else, and it's going to have a big effect. And what this data, these two lines are showing, that whether you include village income or not, it makes no difference. It's really small, statistically insignificant difference. So it doesn't matter whether I include village. That suggests that village income is not very important in that regression. Because if it were very important, then leaving it out would have a big effect. It's a kind of a convoluted way of making this point. That's why it took us 8 minutes to go through this.